So that is a key point was you should know that when when moment of inertia is going to increase, the angular speed will decrease, right? Now, what is moment of inertia? It is mass into, what do you mean by that? Suppose a body is rotating about an axis, or the particle is rotating about an axis. Say this particle P, which is at a distance r from the axis of rotation. I have a mass m. I have a mass m, which is at point P, which is at a distance r from the axis of rotation. Then the moment of inertia. Moment of inertia is the inability of the body to rotate. The body will show some resistance. So that is what we call it as inertia, moment of inertia. I is equal to m into r square. Was very, very, very important concept. You will get a question from here. Right, boys? Just note down, boys. Note down the formula. Sorry. Note down these steps and we'll start doing it.
Ma'am, for Sunday's exam, the derivations and like the derivations are not important, right?
No, only the formulas, and you have to do numerical based on this. So if you have your reference book, Simplified Physics and all, so I'll just give you the key relations. Might be I'll put it in the physics file section. Just first concentrate on all those key things. The one is law of conservation of angular momentum. If tomorrow possible, if I don't have any examination duty, I'll take your class. Just make a note of it. Let's start with a numerical. Shall we move for the next one, boys? Next one, if the earth were very important numerical, if the earth were to suddenly contract to half of its present radius, by what duration would the day be decreased? So what we'll do is initially, let me consider the earth. Earth is a sphere. So always you should by heart the moment of inertia of a sphere. It is 2 by 5 mr squared. Otherwise, this will not be given. So the moment of inertia of this sphere is 2 by 5 mr squared. So initially, the radius of the earth is r1, right? It has a moment of inertia I1, right? And it has a mass m. Now, what happens is that its mass remains a constant, but its radius will decrease. In that case, its volume decreases, density will increase. So its radius R2 becomes equal to R1 by 2. This is the final condition. So you have your Earth, which is in the form of a sphere. Its moment of inertia is 2 by 5 mr squared. Boys, this value is very important. Nobody will supply you this value. You should know. Initially, its radius is I1. Its moment of inertia will be mr1, sorry, 2 by 5. I1 becomes 2 by 5 mr1 square. It has a time period T1, that is 24 hours. Now, next, the earth shrinks, right? Contracts to half of its radius. So your new moment of inertia will be 2 by 5 m. Mass remains the same, r2 squared. So its new time period will be t2. Now the question is, by what duration the day will decrease? So you have to find, what you need to find is t2 minus t1. So first you need to find t2, and sorry, t1 minus t2. That clear, boys? Just make a note of it, then we'll start doing this. Have you all completed, boys? Have you completed it?
The mass will not change.
Mass will remain the same. That is the condition, right? The mass will be the same.
Yes, ma'am.
So what happens? Volume will contract, density will change. Mass remains a constant. So once you have completed, shall I move for the next slide, boys? So now
Can
by
you show the
law of
previous page? Just
okay.
took a screenshot. Yes, ma'am.
By law of conservation of angular momentum, I'm just writing in short form of angular momentum. Your momentum is conserved, which means the initial angular momentum must be equal to final angular momentum. So angular momentum, first formula is very important. L is equal to I omega. So I can write I1 omega 1 must be equal to I2 omega 2. Now it's time period. So I have to relate this to your time period. Angular velocity. These are the formulas which you find. So in that case, I can write this as 2 by 5 m r1 squared. Omega 1 is 2 pi by t1 must be equal to 2 by 5 m r2 squared 2 pi by t2. Right, boys? So now I have to replace r2 in terms of r1. So anyway, I'll cancel 2 by 5 m 2 pi will get cancelled, correct? So I'll be having r1 squared by t1 is equal to r2 squared by t2. So r1 by t1 must be equal to what is r2? It is r1 squared by, because r2 is equal to r1 upon 2. So that will be 4 times t2. Is that correct, boys? So these both will get cancelled off. Or I can write T1 is equal to 4 T2, or T2 is equal to T1 by 4. So what is T1? 24 hours by 4. So T2 is equal to new time period is 6 hours. Correct? Is that correct, boys?
Yes, ma'am.
New time period is 6 hours. So the original time period is 24 hours. Now the time period has reduced. By what amount? Final answer we have to be, so T1 minus T2. So the day has been reduced by 24 minus 6, 18 hours. Is that clear? So your day has been reduced by 18 hours. You have to read the question carefully, boys.
Ma'am, can you show the previous slide for a second?
Should I redo the second one? Should I redo this, boys? Second slide, should I redo?
No, ma'am.
If you are finding it
To the final sphere thing.
working, should I redo the working calendar?
No, ma'am, the previous one. I just want to write the.
I'll redo this. Okay, okay. I'll do. Finding it difficult, I'll redo. Previous one. So now here R1 squared by T1 is equal to R2 squared by T2. This is your first step. Now R2, I have to replace R2 by R1. So R1 squared divided by T1 is equal to R1, R2 I can write it as R1 squared by 4, correct? Divided by T2. Was I'm replacing R2 squared in terms of R1 squared. So now these both will get cancelled. So what is that I'm going to get? T1, sorry, 1 by T1. 1 by T1 is equal to 1 by 4 times T2. Or I can write T1 is equal to 4 T2 or T2 is equal to T1 by 4. So that is 24 by 4. So T2 is 6 hours. The new time period is 6 hours. So by what amount of time the time has been reduced? Decrease in day. So T1 minus T2. So 24 minus 6. So that is 18 hours. And are you clear? Shall I go for the next one?
Yes, ma'am.
Shall I go for the next one? Only thing is that sphere you should know about. Okay, rotational motion. Should I write all the formulas? Shall we go for all the formulas? Okay. Tau is equal to I omega. So I alpha. Tau is equal to I alpha. L is equal to I omega. This is torque. This is your angular momentum. So once you know the formula, you can find what's there is torque can be written as force into distance. L is equal to linear momentum. P is equal to your linear momentum. F is the force. That is M into A. P is linear momentum. That is M into V.
Ma'am,
Yes.
ma'am, if we have to write like torque in the cross product, the vector form, then will it be R cross F or ma'am, is it F cross R?
R cross F.
Okay, okay, ma'am.
Yes. So torque, angular momentum, then you have kinetic energy. This is, I'm talking about rotational kinetic energy. Rotational kinetic energy will be half I omega squared. General formula for moment inertia is mr squared. And law of conservation of angular momentum you have already done. And equations of rotational motion. So that is V is equal to U plus omega is equal to plus alpha t. Then angular displacement half alpha t squared. That is S is equal to UT plus half AT squared. Then V squared is equal to U squared plus 2. These are the equations of motion. So what is omega? Omega is final angular velocity. Omega naught is initial angular velocity. Theta is angular displacement. Alpha is angular acceleration. Correct, boys? And one more relation. Omega is equal to 2 pi mu. Then omega is also equal to 2 pi by t. And nu is equal to 1 by t. Are you clear, boys? So I'll just let me put this in the chat box. When we are solving the numerical, you just check. Yes, I'll put this.
What's MI?
Moment of inertia.
Okay, ma'am.
Because I'm putting all the formulas in your chat box. We'll start with the numerical. Yes. A flywheel of mass 25 kilogram has a radius of 0.2 meter. It makes 240 rotations per minute. When you're talking about rotations per minute, it is linear velocity. Radians per second was. Omega is measured in radians per second. Nu will be measured in rotations per second. So minutes means you have to convert it to seconds. What you get is nu. This you have to convert it to omega. So what is the torque necessary to bring it to rest in 20 seconds? If the torque due to the force is applied tangentially to the rim of the wheel, what is the magnitude of the force? So what is given? M is equal to 25 kilogram. Radius is equal to 0.2 meter. So nu is equal to 240 rotations per minute. So I have to convert it to rotations per second divided by 60. So that is 4 RPS. What is being asked? They are asking you torque. So find torque. And was tau is equal to I alpha. So how will I find for the flywheel? For flywheel, I is equal to half m r squared. M is given, r is also given. So next I have to find angular acceleration. Now for finding the angular acceleration, right, boys, you have to find the body comes to rest, which means what? Omega angular velocity, final angular velocity is 0. You have to find what is omega naught. That you can find from here. This is given in the question. T is given as 20 seconds. So my question is to find alpha first. You find alpha first, you find I next, then you can go for torque. Are you clear, boys? See, the flywheel is making 240 rotations per minute. Then you're applying a torque which brings it to rest. So initial angular velocity will be 2 pi nu naught. So what is that? Omega naught will be 4 pi, so 8 pi, right? Nu naught is RPS, so 8 pi radians per second. Now you have to find what is alpha. Can you find what is alpha, boys? Which formula will you use? I think you're preparing Which formula will you use, boys? Omega is equal to omega naught plus alpha t. First equation of rotational motion. Find this. Boys, find this value.
Ma'am, how
So
did you get
0,
omega is equal to 0?
it finally comes to rest, right?
Yes, ma'am.
The body, so highlighted. The body finally comes to rest.
Yes, ma'am.
This is final angular velocity. Now find what is alpha, boys. So alpha t will be equal to omega minus omega naught, or alpha is equal to omega minus omega naught by t. So it's a deceleration. So minus omega is 0, omega naught is 8 pi divided by what is time? Time is 20 seconds, right? So it becomes equal to 2 by 5. 2 by 5 pi radians per second squared. Correct, boys? Angular velocity. Yeah, angular acceleration. Sorry, angular accelerations 2 pi by 5
negative.
radius. Yeah, negative. And boys. So next you need to find the moment of inertia of the flywheel. Half mr squared I think that you can find, and then find the torque. I is half, m is 25 into 0.04. So find what is the torque, boys. So you are finding what you mean by the torque. What is the value? Are you doing 11B? Are you practicing 11th standard? Are you practicing?
Yes, ma'am.
Now find what is tau. Tell me what is tau. Tau is I alpha. So that is half m r squared. Alpha was 2 by 5 pi, correct? So tau becomes equal to, what is the mass? 25 kilogram. What is the radius? Radius was 0.2. 0.2 the whole square into 2 by 5 pi. So tau is equal to, this becomes 0.04. 25 into 0.04. 2 and 2 will get cancelled. 5 divided by 5, so this goes 5. What's the answer, boys? M is 25, R is 0.2, 0.04, Then 2 by 5 pi. 2 and 2 will get cancelled, so that goes 5.
Ma'am, it is 0.2 pi.
It is 0.25. This value.
0.2.
Okay.
Isn't it
Tau is
suppose?
Is it correct? Just check what we are doing is correct. 25 kilogram is the mass. Radius is 0.2, which means 0.04, correct? Then your angular acceleration was 2 by 5 pi. So you have a pi over there. So I can write this as point.
Wasn't it minus 2 by 5?
Yeah, it's there because the negative term. That's the one which is going to retard the motion. So 20 point. This is the torque, Newton's meter. You can calculate, you can use 3.14. Now the question is find the force which is being applied, tangential force. So the tangential force that is being applied, so tau is equal to F into, this is the radius. So F is equal to tau upon R. So tau is 0.20, sorry, was 5 divided by what is the radius? Radius is 0.2 meters. So F is equal to 5 Newton. Are you getting this, boys?
Yes, ma'am.
Okay. First and foremost, the moment you start your chapter, just all your reference books will have all the formulas. By heart the formula or keep your formula. Formula is very important. You're going for MCQ. So keep your formula properly and start working out. Have you completed? Boys, what's the time? 10 more minutes, right?
Yes, ma'am. Ma'am, can you show the previous slide for a second, ma'am?
Okay. This one?
The one before this. Yeah, this one, yeah. After this. Yeah, this one. Thank you, ma'am.
Should I put this also in space? What
Ma'am, you said
you need
10 more minutes. Period ends at 12:15.
5 more minutes. Okay, 1 second. I'll just finish it. Otherwise, 1 second. Boys. One more numerical. Suppose if angular displacement, I'm just going for one question. If angular displacement at any instant theta is equal to, say, some find angular velocity at time t is equal to 1 second. So what is angular velocity? Omega is equal to d theta by dt. So here 4 into, was I have to differentiate t cube. It becomes 3t squared. 3 comes in front, a power will be less. So next one, it is, if you differentiate t, you will get 1 plus constant is 0. So omega is equal to 12t squared plus 2. So omega at time t is equal to 1 second. Omega becomes equal to 12 into 1 the whole square plus 2. So 12 plus 2, it is 14 radians per second. Are you clear, boys? It's 4t cube. Copy down, boss. Stress versus strain graph, very important graph for all the examination in terms of your examination point of view. So stress strain graph you need to learn both. Is that you people are being left at 15, 12, 15 or 12, 20?
Ma'am, it's 12:15.
Generally, you will be left at 12, 20, right?
No, ma'am, we're left at 12:15, and then we joined the exam call at 12:25. In normal timings, we are from 12:15 to 12:35. We have a break.
Okay. Sure, okay, you can leave, boys. You can leave. So let me see. Tomorrow, if possible, I'll take your class teacher's paper. You can leave, boys. You can leave.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.